12 miles outside of downtown Boston, there's a bank unlike any other.
All right, thank you very much. Thank you. All right, good night.
Good night.
Tonight, a deposit is about to be made. Here at the Brain Bank, a mind is a terrible thing to waste. In a 3-pound mass of tissue about the size of a grapefruit, the human brain guards the secrets of what makes us, us. Until recently, the brain was regarded as a black box whose secrets were secure from reach. But now, scientists are creating a revolution in imaging, genetics, and molecular biology that is unlocking the box. As we open the lid, we are beginning to understand evolution's most miraculous achievement. And as the brain offers up its secrets, our ability to tap its real potential may be at our fingertips. We are beginning to harness the brain's incredible ability to invent itself, then reinvent itself throughout life. This girl is a testament to the amazing resilience of the human brain. Young Jody Miller leads an idyllic life as a 9-year-old girl. You would never guess that she has undergone some of the most drastic surgery imaginable. Jody's first 3 years were textbook normal.
Happy birthday, dear Jody.
Then, about 6 weeks after her 3rd birthday, a storm of epileptic seizures took control of her brain.
She couldn't use her left arm hardly at all. She could barely use the left leg, seizing a good deal of the time, multiple types of seizures.
Ordinary life became impossible. Medicines did nothing, and the seizures threatened to turn fatal. Desperate, Jody's parents brought her to pediatric neurologist Eileen Vining.
We found her seizures were all coming from her right hemisphere. And we knew that there is virtually nothing else, nothing but Rasmussen syndrome that can produce that picture in a young child.
Rasmussen syndrome is a degenerative brain disorder that disrupts the electrical activity that makes our brains work. Tiny electrical explosions were flaring up in Jody's right hemisphere. As seizures became almost constant, she lost control of her left side. Only one radical treatment option remained.
We knew that she was never going to have her seizures controlled with medicine, and we knew that she and her family faced taking out that half of the brain.
Okay.
Dr. Vining recommended a daring surgery called a hemispherectomy. It would be performed by pediatric neurosurgeon Ben Carson.
The whole concept of taking out half of a person's brain would seem to most people impossible. Human beings are incredible creatures with a brain that is beyond belief in terms of its capabilities, to the point where we can take half of it out and still function in a normal way.
85% of our brain consists of the cerebral cortex, which is divided into 2 hemispheres, each with 4 main lobes. The cortex handles many of our higher functions. Areas on both sides control thinking, movement, and sensation. But the right side controls our left side and vice versa. Jody would lose almost all of her right hemisphere, and the cavity would fill with cerebrospinal fluid. The operation has to be performed with great precision to avoid damaging the parts of the brain that control Jody's life functions, like heartbeat and breathing. The surgery went flawlessly.
What we're looking at here is an image, an MRI, that was done on Jody after her surgery. And what it shows us is the fact that we removed her entire right hemisphere. And what we're able to see here is indeed her very normal left hemisphere and all the beautiful gyri of her cortex. And we can see right down the middle, the right hemisphere that was there is now replaced by fluid.
But how could Jody function normally with only one hemisphere? It's because of a miraculous ability of the brain called plasticity. Our brains can actually change shape, creating new connections between neurons or brain cells to replace lost or damaged ones. Jody's left brain started reconnecting almost immediately.
At least as good as this. And if I remember, he wore pink just like you. This young lady had half her brain removed, went home, I guess maybe 10 days later, and was already walking. She was ambulating. She was able to walk out of the hospital. And that's because her left hemisphere had such resilience, such plasticity. It was able to say, okay, something needs to move her left leg. Whoa. You gonna open it? Okay.
Jody continues to work on training her brain to overcome the slight paralysis in her left side.
But enough, now that's very good. You need to do that stretching stuff, honey. You know that, don't you? Are you doing enough of it? I think so.
It begins with a few cells at the tip of an embryo. Brain cells, neurons, multiply at an astounding rate, 250,000 a minute. At only 5 months, this fetus is well on its way to developing most of the neurons it will ever have, about 100 billion. But it's not the number of neurons that make the brain work so brilliantly. It's the fact that they communicate with each other. Each tiny neuron can make up to 10,000 connections. When neurons connect, networks start to form, allowing electrochemical messages to pass between them. In a couple of years, those 100 billion neurons will make 1,000 trillion connections. We've known for decades that genes dictate the basic structure of the brain's networks. But what we've started to understand is that it is our experiences that complete the brain and make us who we are. Sensation, movement, and even play shape a child's brain. Each experience reinforces some connections. These are the ones that will be retained throughout life, creating our senses, our ability to imagine, to learn, even to love. In other words, that make us who we are. The capacity for learning is greatest when we are very young, but as we grow older, it diminishes. There are critical windows for making the proper connections for some of our most important functions. Liz Ortner is in danger of missing one of those critical periods. She was adopted when she was 2 months old, and her parents soon began to suspect that she was deaf.
We even had the perfect test. All the kids were asleep except for her. And she usually goes berserko when Daddy comes home. Told him, just come in and call her from behind. He came in the house and he yelled at her and he called her name and he got 2 feet away from her and she still had not a clue. And as soon as he touched her, then she went crazy and was, happy to see him. So we knew something was wrong.
Normally, sound vibrations are converted into electrical impulses in the inner ear. The signals travel over the neural network to the part of the brain that perceives sound, which lies within the temporal lobe and is known as the auditory cortex. But Liz's ears had been damaged by an infection before she was born, and her brain isn't receiving any stimuli from sound. Her doctor, John Niparko, knows that it can affect more than just her hearing.
There is a period of time early in life when Mother Nature devotes tremendous resources to development of the brain. During that time, normally, brain circuits are being refined, and that refinement allows a child to develop language. Without sound stimulation, we know that what happens is that there is a narrowing of the potential of the brain to use sound information later on. And so this very expensive period of development is essentially wasted. Did you get some sleep last night?
About 2 hours. I hope you're well rested.
Yes, we're all set to go.
I don't want you to carve too deep into her skull.
Absolutely.
Okay.
We'll be very careful about
I just
that.
had to say that. Okay.
Liz is now 14 months old. As each day passes, she's getting closer to missing the critical period in which she can easily learn to talk. Today, she'll get a chance at beating the deadline. A surgical team will insert an ingenious device called a cochlear implant into her inner ear. If it works, it will help reactivate her hearing pathways, transmitting electrical impulses to her auditory cortex. She will be able to hear.
Our surgical approach will be to come behind the ear, as you can see right here, and to open up this air cell system. It's a little bit narrow in a young child, as you'd expect, but I'm going to plan on placing the device right about this location on the skull, up and behind the ear. This should be a nice location for her.
Liz is one of the youngest children ever to receive a cochlear implant, which gives her the best possible chance to catch up.
Charlotte.
The operation takes only 2 hours.
Those are all very acceptable values, and we know we have a good location of all of those contacts. We're all set. No problems, no surprises. The entire implant fed in very nicely. We checked all
Expectations are high, but it will be a month before the implant can be activated. Liz needs time to heal. 4 weeks later, the Ortners, hopeful but anxious, make the drive back to the hospital.
So it's here, finally. We've all been counting down the days. This is a big day for her. Like it's like being born into a new sense. Christy, we won't have to whisper to her. I think she'll be shocked. I think she'll be scared. You know, if I see her just, look at me and smile with wide eyes, I'll be ecstatic. If I see her cry, I'll cry with her. I can't imagine finding a new sense. And that's what she's going to be doing. She's heard nothing, ever.
Hi. Hi, pretty girl. I'll go ahead and start with a very, very, very soft presentation of what will sound like to her, like a beep, beep, beep. So sound to her is something very foreign.
She might ignore it.
She might ignore it, or she might get upset. She might grab you. I'm going to go ahead and start, and these, I do not expect her to hear these in the beginning, okay?
Liz is intent on her game, while everyone watches carefully for any response to a soft beep.
Does she blink it out?
The audiologist increases the volume just slightly.
Yay! Did you hear that? Did you hear it?
Liz Ortner has heard her first sounds. Her brain can now begin the process of connecting itself for hearing and for speech. If all goes well, she should be talking within 2 years.
It's going to be a lot of work, and I know it's going to take a long time. I know that it'll be a year. I expect it to be a year before she understands her name. I'm not in it for today or for a year. I'm in it for when she's 30 and beyond.
Memory, our mind's very own DVR, a vital part of who we are.
Our identity is based on our memory.
Mysterious, miraculous, and now amazing new possibilities.
This is quite a striking finding.
Will we soon be able to choose which memories we save and which we delete?
We're really on the verge of an important breakthrough.
A Life in Memory. Premieres Sunday at 9, part of SciQ Sundays.
Only on the Science Channel.
During childhood, the brain manufactures billions more connections than it can ever use, giving each of us innumerable options about what we learn and in what we can excel. But it's a case of use it or lose it. As childhood ends, a dramatic pruning process occurs. The well-used connections are strengthened. Seldom used links die off. By the time we're teenagers, only half of them remain. But that's just part of the story. There's a lot more going on inside the teen brain, though at times it seems like less.
You don't really know where you're gonna go until that minute, and then you end up somewhere.
You can't plan like what you're gonna do on the weekends, because anything can happen.
I just wanted to do it, just because of the luck.
It's probably like, it's like...
One day I just said, let's do it, so I just did it.
Randomness is sometimes exciting.
Recently, science has confirmed what parents have suspected for eons. The teen brain really is different. Dr. Jurgelin Todd has observed some profound differences in how teens and adults process emotional information.
Essentially, when we compared adult brains to teenage brains, what we found was that adults use their frontal cortex to process information, whereas teenagers use an older part of the brain, the amygdala, to process information.
The amygdala was one of the early structures to develop as our brains evolved. It's where instinctive reactions, such as anger and fear, reside. It may not be surprising that the teen brain uses it much more than the adult brain does. As we mature, stronger connections are made among the different structures in our brains. The instinctive reactions of the amygdala become tempered by the frontal cortex, which is the human brain's crowning achievement. It's where planning, reason, and moral judgment reside. Recent breakthroughs in understanding the brain have come about because of new technologies like the functional MRI, or fMRI. Beginning in 1994, it revolutionized brain research by capturing detailed pictures of our minds at work.
Come on over. Do you have anything in your pockets?
The more scientists see, the more complex the picture becomes. The ever-changing mind is like a film that is constantly being re-edited at an astounding pace, producing a new story for us every single moment. At Massachusetts General Hospital in Boston, Dr. Kathy O'Craven is using the fMRI to create snapshots of us seeing by scanning the brain as it processes visual information.
What's going to happen is you'll be seeing images appear on that screen, and what I want you to do is just look at the pictures and try to identify the people and the places that you see.
Images of famous faces and places are projected onto a screen. As the subject views them, Dr. O'Craven records his brain activity.
We can actually tell whether or not the activity is different when they're processing different kinds of images. So while he's looking at these pictures, we can actually localize the two parts of his brain that are involved in processing those two kinds of stimuli.
When she looks at the data, O'Craven can read the mind of her subject. She can tell what the subject was thinking about, a face or a place.
If we look within the region where the place area is, and we see this kind of activity, these bumps, this is how strong the signal was, the brain activity, as a function of time. This is when the subject was looking at faces. This is when he was looking at places. Faces again, places again, faces again, places again.
The fMRI can take a snapshot of the brain every half second, but that's a snail's pace compared to the super speed of brain activity, which processes hundreds of thousands of signals every second. Now there's a new invention that captures moving images of the brain's activity. In 1999, by combining the fMRI with a process called magnetoencephalography, scientists at Mass General made the first ever movies of the brain at work. The imaging team at Mass General is headed by Dr. Bruce Rosen.
The movies of brain activity that we're generating are really at the cutting edge of brain mapping technology because they combine the high resolution of fMRI and the high temporal resolution, the ability to see in time, of MEG.
These images have been slowed down to show how a thought can flicker across a brain in milliseconds. They reveal a brain that is amazingly dynamic.
We can actually watch that information in the brain is not static, and nor does it occur only in one direction, but it's actually kind of an ebb and flow of information from one part of the brain to another, information fed back again in a very complex way that we're really only now just beginning to see, much less to fully understand.
All this activity is made possible by one thing, brain chemistry, which enables the transmission of signals within the brain. Chemistry between people is more than just a turn of phrase, and recent research may be leading to some new insights into the most mysterious of human feelings, love. One study is investigating how the mind produces those tender, passionate moments, even in rodents.
They're pretty cute in their own way. They can bite, but you have to be amazed by the level of their social behavior, the fact that they will form these long-term relationships and that they are so incredibly faithful. That by itself is remarkable.
Dr. Tom Insel is fascinated by the brain of an affectionate, unassuming little creature called a prairie vole, which is one of the few mammals that mates for life.
They go through a remarkable life change at the time that they mate. Thereafter, both the male and female show these profound behavioral differences. The female shows a lifelong preference for the mate that she's just spent time with. Now, the question has become then, what is happening in the brain that goes with this personality change? What's taking place in the brain?
To find out, Dr. Insel began to observe the dating habits of the female vole. She checks out the first male, whom she's never met. She's not impressed. But when she reaches the other male, with whom she's mated, it's clear she's found her sweetheart. When Insel examined the vole's brains, he discovered that two substances were released when they mated, called oxytocin and vasopressin. They are neurotransmitters, the chemicals that carry messages along the neural networks. These two are made in a part of the brain called the hypothalamus, which is connected to virtually every other part of the brain. The hypothalamus is the source of some of our most basic instincts, including desire.
They turn on circuits that are important for reinforcement. From the animal's perspective, they want more and more of what they've just experienced. What we're calling social attachment, in some way, is the craving for being with the mate with whom they've experienced this very special neurochemical moment.
Do people, too, become addicted to love?
We do know that the human brain has oxytocin and vasopressin. We know as well that those hormones are released with mating in humans.
Does Insel think love is just biochemistry?
For me, the biology in no way detracts from the romance of love. For me, the biology makes it more mysterious, more awesome, more powerful, in fact.
The brain is truly a marvelous creation, the pinnacle of millions of years of evolution. It has been compared to an orchestra, with many components performing as instruments. playing brilliantly together to create the music of our minds. Each thought is a triumph of harmony and synthesis among billions of neurons. Our brains may actually remember everything we've ever seen, experienced, and imagined, and it uses those memories to create an organized view of the world. But if our brains cannot draw upon our memories in a coherent way, the result is dissonance. Marion Krause was 27 years old when the first signs of her schizophrenia showed up. She's a patient at the National Institute of Mental Health in Bethesda, Maryland.
Hello, Dr. Weinberger. A few weeks ago, I was having like a lot of delusional thinking. 6 or 7 months before I got sick, I was kind of depressed.
She's participating in a study run by Dr. Daniel Weinberger. He wants to know what physically happens in the brains of schizophrenics.
Well, then in October of '97, I was transferred from one ship to another. And
Marion was a damage control firefighter in the Navy when paranoid delusions first began to take over her mind.
on the second ship,
They quickly destroyed her career.
one day. Also, I started thinking that there was a conspiracy of people who intended harm to everybody who has a J in their name, who does not evangelize for the conspiracy.
What could be responsible for the bizarre and destructive delusions of the schizophrenic?
And I could not find
Dr. Weinberger is among those who suspect that early damage to certain structures in the brain, maybe even in utero, could cause the neural networks to go haywire later in life.
in his hand.
Many of the brain imaging studies that have been done in schizophrenia have shown that the frontal lobe is not physiologically working correctly. Another region of the brain, the temporal lobe, called the hippocampus, is also abnormal. This is a part of the brain that's very important for comparing sensory stimuli to what you've experienced in the past.
The hippocampus files memories and retrieves them for use by the frontal lobe, which takes the data and interprets it, makes decisions, and takes action. Weinberger hypothesized that if the hippocampus was abnormal in a fetus or child, it would cause disorder in the wiring of the frontal lobe. To test his theory, he damaged the hippocampuses of newborn rats.
As they became young adults, they all of a sudden began to manifest a constellation of abnormalities. They were hyper, they were abnormal, overreactive to stress, that while they didn't complain of hallucinations and delusions, but at the biological level of a rat, looked remarkably similar to what we see in human beings with schizophrenia.
The brain's intricate networks need to develop unimpeded in those early years when the brain is at its most vulnerable.
And the assumption is that when you create mischief, molecular mischief, in the brain of a developing animal, or human possibly, you cause rewiring and reorganization of many, many parts of the brain that you would not predict if you did the same kind of damage to a brain that got wired normally.
In the schizophrenic's brain, if the network connecting the hippocampus and the frontal lobe is disrupted, perhaps the ability to use memory to make sense of the world is scrambled.
Many patients with schizophrenia describe the feeling that they feel that they are disintegrating, that their brain is disintegrating, that their mind is disintegrating, which is terrifying.
Yeah. Sometimes I'll be outside having a cigarette, and the air vents will they make a little bit of a noise, and then they'll start to seem like they're taking on a rhythm, and then I'll start hearing stringed instruments, then I'll start hearing humming, and it's a little nerve-wracking. I just can't hear them because I'm so, there's a sort of a soundtrack that goes along with my delusions. The voices don't sound like they're coming from across the room or from somewhere else, but they sound like they're, embedded in my head.
For the schizophrenic, the orchestra plays out of tune, distorting the normal variations a healthy brain produces. Throughout our adult lives, our brains perform effortlessly, never tiring, never resting. Even when stricken, they are capable of remarkable feats of rejuvenation. Dr. Jill Bolte Taylor was a rising star in the world of neuroscience. She was at Harvard Medical School, specializing in neuroanatomy, when something went terribly wrong in her own brain.
When I first woke up and opened my eyes, I felt this pounding behind my left eye, a pounding. And I wiggled my fingers in front of my face, and it was as though they just looked kind of silly. And then in the next instant, my right arm went totally dead. And it was in that moment, you know, my first thing my brain says is, oh my gosh, I'm having a stroke. And then the next thing my brain says is, wow, this is so cool.
Jill needed to call for help, but when she tried to phone her office, she couldn't remember the number. And when she looked for her business card, she found her brain was unable to distinguish numbers from letters. It took her 2 hours to work it out.
I try to say, in my mind, I say, this is Jill, I'm having a stroke. And it was in this moment that I realized that's not what came out of my mouth. What came out of my mouth was, it was this sound, but it was not language.
During a stroke, the blood flow to part of the brain is blocked off. The results can be devastating. Millions of neurons may die. Others may be temporarily stunned. Still other undamaged cells may be unable to send or receive messages because they are connected to dead cells. It's as though the phone line has been cut. At Mass General Hospital, surgeons operated on a golf ball-sized hemorrhage in Jill's left temporal lobe. A clot was placing pressure on 2 areas that handle language. At age 37, she could no longer talk, understand speech, or even recognize color. She would have to try to rebuild her brain by retraining undamaged neural networks to take on new roles. It was impossible to know just how much function Jill would recover.
So here I am, and I'm holding these pieces, and I'm trying to match the size of this piece with the size of that, and then Mama says, color, you can use color. And I'm going, color? And all of a sudden it was like, oh, wow, yeah, that makes it a lot easier. But prior to that, I didn't even see the color. It was just, you know, brand new information to my mind. And so I went back to the puzzle and put all the pieces together. It was like, for my mind, all these files existed. I just needed to know that they existed, and I needed to open them. I understood that the sooner my mind reestablished its connections that had been broken, then the easier it would be for me to relearn.
Jill had lost some of her most basic functions, but she had a chance to undergo a transformation that few of us experience.
Okay.
Most of us have a dominant hemisphere, the side of the brain we rely on. Jill was left-brained, which is the more organized and systematic side.
I had been a highly analytical human being, very thinking, very cognitive, left hemisphered kind of person, and I was climbing the Harvard ladder, and, you know, my career was everything. At the point that the left hemisphere shut down, all the inhibitions got shut down off that right hemisphere, and I didn't have a left hemisphere, but now I had this very interesting right hemisphere to work with. So my perspectives shifted in what I looked at and how I saw things. My art and my music began to flourish.
When Jill's right hemisphere came to the rescue, she began to process information in a more visual, imaginative, emotional way. Jill began to create a very personal form of art, stained glass brains.
And so I went to my neuro books and I spread them all out on my table, and I started thinking, okay, if I wanted to make a stained glass brain, because I thought it would be gorgeous, what would the pattern have to look like? What's in there? And what can I show in two-dimensionality? I think that the brain is this incredible, beautiful organ that allows us to have this existence in this three-dimensional world.
Today, Jill has found a new balance in her life. But first, she had to wrestle with a fundamental change in who she is.
what am I going to build my life into now? And how am I going to help people understand that I might look like me, I might sound like me, but I'm different now. That person died that morning. And I had to allow myself to let go of returning to her, because she had a big life. You know, she had a big life, and I may never go back to that big life, but I could build a new big life, and that needed to be okay.
As we age, the brain, like the rest of our body, becomes more vulnerable. But powerful evidence is emerging that the brain works like a muscle. The more we use it, the stronger it becomes. An active mind helps grow new connections in the brain. And the more connections we create, the more reserves we have to combat the effects of old age. The benefits are not only physical, however. Exercising the mind is key to keeping it sharp. Harry Shapiro, a retired commercial artist, was born in 1899. He has made it to this age with flying colors. No cancer, no heart disease, a sharp mind, and a good sense of humor.
I was the firstborn in my family. My mother had 6 children. I was one of them. June, July, August, 6 more months. I'll be 100 years old. Sometimes it feels that way. And sometimes I feel I was born yesterday.
He likes Chinese food, good pipe tobacco, Bach and Beethoven. In fact, music even inspires his painting.
Primitive dance. It's from Beethoven's 7th Symphony. The third movement is a dance, a primitive dance. And that's where I got my idea from. I like to feel that there's a musical quality in this. That you can almost, I hum as I paint sometimes. It's all over this.
Harry is the most recent addition to the New England Centenarian Study, which is documenting people who have reached 100.
I'll just say the numbers and you say them right after me.
Dr. Marjorie Silver, who heads up the study, is testing Harry's mental ability.
I think the key is that the more you learn, the more you're able to learn. So the people who continue to meet new challenges, to learn new things, are the people whose minds are going to stay very sharp into old age. Are you ready? 2, 5.
2, 5.
3, 1. I was really surprised that he could repeat 8 digits, which is a test of attention. There's only one other centenarian that did that, and she had been a bookkeeper.
5, 9, 2, 8, 4.
Well, you did very well. This 100-year-old man was doing well above what the average person does at a much younger age.
This is similar, this is different.
That's right. What was really typical about him was his constant learning. He was constantly thinking of new things. He loved to learn. He describes himself as a little boy, loving to learn things, and that lasted his entire life. And consequently, every time he learned something, his brain was building up more ability to learn. It was building new pathways, new connections between the neurons. Therefore, he's really built up a functional reserve that really helps keep his mind working very well.
I think the reason I've lasted so long on this earth is because of my love of painting and music and literature. Things that lift the spirit of man up.
The more we learn about the brain, the more awesome it appears. We're on the threshold of using our newfound knowledge to tap its potential in ways we could never have dreamt, even in the most severely damaged brains. Johnny Ray was having a pretty good life.
Had his own rules, made his own hours, just did whatever he wanted to do. Married with a family. He was just a 52-year-old drywall contractor that'd been in it all his life, that worked 7 days a week.
Then suddenly, a blood vessel burst in his brainstem. The extensive damage left him unable to move or speak. But his doctors knew he was alert.
So he could still think. He could still be able to communicate ideas. He was able to show us that by eye blink, so we knew there was ability, there was something inside there that could respond.
His doctors came up with a revolutionary idea that depended on his brain's plasticity. If it worked, it would change the boundaries of medicine. They implanted a tiny cone containing 2 specially treated electrodes into the part of his brain that controlled his hand movement.
The unique aspect of this electrode is that it's glass-coated, and it has substances that stimulate nerve cells to grow in and form contacts, what I call synapses.
Then they waited to see if his neurons would grow new connections into the electrodes. If they did, it might be possible to capture the electrical energy of the neurons and use it to connect Johnny Ray's brain directly to a computer. Dr. Philip Kennedy, who invented the device, believed that when Johnny thought about moving his hand, his neurons would fire, and this electrical signal could be used to move a cursor. But was it really possible to create a circuit between a human brain and a machine? After 3 months of testing, there was little progress. Then finally, something astonishing happened. On July 2nd, 1998, when Johnny Ray thought about moving his hand, the cursor moved.
He thinks about it, it moves. The cursor moves by his thought. He thinks about it, the environment is changed by his thought. We are interacting with the environment directly now, being able to control our environment by thinking about it.
Hi, my name is Johnny Ray. Make a move across, Johnny, and hold it there. My name is Johnny.
Johnny Ray is using the electrochemical processes in his own brain to run an external mechanical device.
I feel too warm. He was able to drive the cursor across the screen from left to right. He was able to enter each icon and remain there for the 2 seconds while it said what it was going to say.
It's a new level of mind over matter, and it opens a whole world for Johnny Ray and others like him.
The communication aspect is tremendous. You can type your name and you can write a letter. You can send an email. You can receive email. The potential is to put him on the internet, to allow him to communicate with other people that have diseases, disabilities, allow him to express himself. He has a personality under all this that he can't express in any other form.
On an all-new SciQ Sunday, Memory, our mind's very own DVR, a vital part of who we are.
Our identity is based on our memories.
Mysterious, miraculous, and now amazing new possibilities.
This is quite a striking finding.
Will we soon be able to choose which memories we save and which we delete?
We're really on the verge of an important breakthrough.
The miracle of the human brain is heightened by the possibilities that lie before us.
Understanding how the brain works is really understanding what we are as people. It should allow us to not only understand discrete functions like memory or language or vision, but should also allow us to study questions like human imagination, human consciousness.
The men and women who are searching inside the brain remain in awe of it, no matter how much they discover about its innermost workings.
The human brain is probably considered our most sacred of organs. It's what defines us generally, really, as human beings.
The human brain is just an awesome thing because every time I look at it, I say to myself, this is the thing that makes this person unique.
To comprehend that which enables comprehension is the ultimate search for who we are. To understand our own brain is one response to the profound challenge issued from the mind of a great philosopher: know thyself.